Welcome to today's FabFems Friday with a focus on chemical engineering. We have a fabulous lineup today as well as through the end of July. So we hope you come back and continue to join us as we have these weekly discussions with our fabulous currents and alumni and engineering friends from the community. I'm Trisha Berry. I use she, her pronouns. I'm the director of the Women in Engineering program in the Cockrell School of Engineering at UT Austin. I'm also a chemical engineer. So this is one of my favorite ones of these to do because all of these folks and the work that they do are near and dear to my heart as a fellow chemical engineer. You can find today's panelists lots of amazing STEM role models in the FabFems database. The FabFems database is a national database of women in STEM professions. And they are lots of different inspiring role models. You can search on keyword or a lot of different factors like zip code or field of work, interest of engineering, and get connected up with other fabulous role models to keep exploring our different kinds of engineering disciplines and STEM disciplines. So I encourage you to check that out. We also have lots of questions that we're going to address today and more that are on our frequently asked questions on our YouTube playlists. We continually add videos and respond to questions submitted by our summer camp students and our incoming students and our broader community. So we'll make sure to share out with you as those get more and more populated. And I'm going to throw in the chat some links for you. This takes you to some of the spaces that I just mentioned where you can find more information. So please check those out. Today, we welcome chemical engineering students and alumni, and we're going to have each panelist introduce themselves here in a moment to get us started. And after introductions, I have a few questions, pre-selected questions from them that have come in, but then we're also going to take questions from you, from the audience. So again, please use that Q&A space to submit your questions at any time. So with that, I'm going to turn it over to our fabulous panelists, and I'll just call you all out as we go through to have you each introduce yourselves so that we can get to know you a little bit better. And in the meantime, our fabulous WEP crew members, Maya and Sarah, are monitoring the chat, and they will be helping us facilitate the questions in the Q&A pod when we get a little bit later on in our webinar. So with that, let me start with Brittany. Brittany, can you tell us a little bit about who you are?
Of course. Hi, everyone. Thank you for joining us today. As Trisha stated, my name is Brittany Johnson. I use she, her pronouns. I'm from Houston, Texas, and I got my Bachelor of Science degree in chemical engineering around 11 years ago now. So I've been out of school quite a bit. I'm currently a commercial asset manager with Enterprise Products. And a couple things I like to do outside of work. Love to work out, go on walks with my 2-year-old Maltipoo, and my all-time favorite thing to do is travel, which has been a little challenging given the climate that we're in, but happy to start venturing out again, within the next few months. So again, thank you guys for being here. I look forward to speaking with you.
Awesome. I think we all want that travel to come back into play a little bit more. That's awesome. I saw lots of nodding when you were sharing that. Becky, tell us a little bit about you.
Hello, my name is Becky. I'm from Edinburgh, Texas. I use she, her pronouns, and I'm a third-year chemical engineering student with a minor in business. And one of the things I love to do, which is what I was going to say, is travel. So this summer, I've definitely taken advantage of things opening up. I was in Denmark this past month studying abroad, and I'm going to head to Mexico City next week. So it's like I've been taking advantage of that this summer. Things are slowly opening up. So that's something I absolutely love to do.
That's fabulous. Jane, let's hear from you.
Hi, everyone. My name is Jane. Pronouns are she, her. I'm from Houston, Texas, and I'm a current student going into my 5th year and my last semester for chemical engineering. Outside of engineering, I am very outdoorsy, so I love to camp, canoe, hike, anything like that. If I can be outside 24/7, I would live in a tent. So that is me.
Thanks, Jane. Sarah.
Hi, everyone. I'm Sarah Bradshaw. I use she, her pronouns. I have an undergraduate degree in chemical engineering with an emphasis in nanotechnology and a master's in materials engineering from USC. So right now I am a section manager over the photolithography group at Texas Instruments in one of our semiconductor manufacturing facilities. And like everyone else, I also love to travel. I head to the Bahamas in a week. So I am very excited to be getting back out there again. Got a lot of trips lined up for the rest of the year. A lot of unused time off to take advantage of.
That's awesome, Sarah. And Texas Instruments is one of our summer camp supporters and Women in Engineering program partners. So shout out to Texas Instruments for supporting all of you summer campers that are joining in on the webinar today. All right, so let's get into our questions then. Sarah and Brittany, let's start with you. So what made you decide to pursue chemical engineering, and maybe talk a little bit about how that applies to the work that you're doing now in your field?
I'll go first. So I decided to pursue chemical engineering my junior year of high school. So at that time, I was an athlete. I played basketball and softball. And initially, going into high school, I thought, it really honestly didn't matter what I did. I was going to go play ball professionally and do that for years after school. But, after a couple years in high school, I decided I didn't do that anymore. So, speaking with a friend of my mother who is a mechanical engineer, and I was telling her I was, trying to figure out what I wanted to do. And all I knew is that I loved math and science. And she kind of pointed me in the direction of chemical engineering. Hadn't heard of it prior to that, but just, did some research, and it sounded like something I was interested in. It sounded like something I wanted to pursue. And so fortunately enough for me, I was able to get a summer internship the summer after I graduated high school. And it was with PepsiCo. And while it differed from the oil and gas industry that I chose to go in, it gave me enough, it provided enough of an experience for me to let me know that this is something I wanted to pursue moving forward. So, after that, I just came into UT my freshman year with an engineering degree, and fortunately enough, loved it enough to pursue it. And it's worked out for me to this day. And so when I initially went to work, I was doing process design engineering, sizing PSVs for some of the larger refiners in the Houston area. And, having that background of engineering definitely helped me with some of the design challenges that I had in that first role. So it's kind of how I got on the path, got on that path, I should say.
Yeah, I guess I had a kind of roundabout way to land where I currently am. So my dad was an electrical engineer, and I loved chemistry and biology. So when I was looking, at degrees, I applied to half my schools as a biomedical engineer and half of them as a chemical engineer. And I kind of figured, based on the school I got into, that was the degree I was going to go with, and we'd figure it out from there. Kind of realized after that, having been in it for a while, that a biomedical engineer won't necessarily get hired at, like an oil company or a semiconductor company like ChE, but a chemical engineer will definitely get hired at a biomedical company. So I'd say kind of that broader scope led me to stay with chemical engineering. But as I went through my classes, a lot of petroleum classes, and that wasn't really what I found myself enjoying doing. So I had to kind of step back and say, what else is out there? Thought I would go maybe into Northrop's space program, talk to them, because I have a master's in materials engineering. They told me I needed semiconductor experience. So I went and got an internship at TI, and then I loved it, and I've been here ever since. So yeah, maybe from like biomedical to semiconductors, it's been a weaving path, but led me to a place I'm very happy to be at.
Awesome. And we always get a lot of questions about kind of this, what does your pathway look like, but also what are some of those intersections of the different disciplines and how does it all combine? So that's helpful for everyone. Thank you. Well, let me start with Becky and Jane. What made you decide to major in chemical engineering, and what work do you think you want to do with this degree when you graduate?
Yeah, I can go first. So for me, like similar to like Brittany and Sarah, like in high school, I right away knew that I had a passion for chemistry. Like I absolutely loved it. And it came specifically from a high school teacher, my high school chemistry teacher. So I knew I wanted to go into that, but I wasn't sure if like I wanted to do chemistry or chemical engineering. So similar to what Sarah did. Some of my schools I applied just as a chemistry major and some of them as the chemical engineering, and then kind of went off of that as well. But I right away fell in love with ChE. And then for me, something that I need to learn what ChE was, because I was really confused. I was like, I don't even know what this is, but I know it's something I want to do. So now as a third year, I'm kind of like seeing these different careers that you can take. So for me, I definitely want to do something that helps people. So I know I'm either going to go into something sustainable. So right now with UChEW, which I'll talk about later, like I'm their sustainability officer. So I want to do something either in sustainability or in pharmaceutical, which is something that also I'm attracted to as well. So those are two different routes that I'm currently trying to pursue and investigate and learn more about. But yeah, that's my route to ChE.
My route sounds really similar to Becky's. Actually, I had an excellent high school chemistry teacher. Loved chemistry and knew I wanted to do something with it. And then maybe because I'm in the Houston area, chemical engineering is pretty big. So I felt like a lot of people in my high school went into chemical engineering. So I was like, okay, why not? So I went into that. And then kind of my interest at first was material science. I liked the idea of like coming up with like less environmentally impactful, like building materials or like packaging materials or something like that. So that was what I was really interested in coming in. And then as I've gotten further in the degree, I actually ended up adding a double major in sustainability which is in the College of Liberal Arts, to kind of get more of that, like it still suits my interests in like environmental advocacy and stuff, but it's less STEM and a lot more kind of like policy and I guess like social movements of environmentalism. And that then influenced my like thoughts further about what I wanted to do with engineering. So now that I'm going into like the end of my engineering degree, I think what interests me most is like environmental policy. And there's not very many like engineers or really STEM professionals in policy, or there are a lot, but not as many as there should be, I think. So I think kind of bridging the gap between engineers and all of the like incredible environmental research that's being done with like politicians and like social groups would be really cool. So that's what I'm thinking of doing afterwards.
Awesome. Thank you, Jane. So Becky, let's come back to you and talk a little bit about UChEW. So what is UChEW? What does that stand for? How did you get involved? And what are you looking forward to this next year as an officer?
Yeah, of course. So let's just start off with what UChEW is. So it stands for Undergrad ChE Women. But we're definitely open to absolutely anybody. For me, I got involved my first year. My first year I was kind of looking for an org to like be a part of. I know you guys are going to see a whole lot of them once we come back in the fall. So for me, UChEW just fit in right away. I felt really comfortable. It was small. So with UChEW, you'll find a lot of academic support. So you'll find people like, hey, I have class with you. Let's go study. So we're all ChE, so we'll have classes together. But not only like academic support, but I have a lot of friends there. I met a lot of people there. Turns out some of us lived in the same dorm. So you guys get to hang out like outside of classes and stuff. So you kind of start building your own community. The reason that I really liked it, like I said, I felt comfortable. It was very welcoming. It had such a like peace to it. I don't know, like I went to other ChE orgs and they were just a little too big for me or a little too crowded, or just I felt really small. But with UChEW, I definitely felt heard and like I knew I wanted to be a part of it. Something where I'm pretty sure all of us are excited for in the fall is simply to be back in person, to be able to go to an org meeting and like eat food together or however that's going to work. We're all really looking forward to that. I serve as a sustainability officer, like I said. So right now I have this project going for UChEW that I'm in charge of, which is like, I'm just going to share real quick just so you guys know. It's like an eco brick project. We're getting plastic and stuffing it inside water bottles and making this brick-like structure. So I know throughout the summer and this past year, we built a series of bricks and we're hoping to build like a structure out of them. So it's something exciting we have going on. And just like that, many other orgs will have their own projects to be a part of. But for UChEW, you guys can definitely find us like on Instagram at Texas UChEW, how it's spelled. I think you guys can see how it's spelled there. And then there you can find our website and simply just get involved and learn more about who we are. And hopefully we can see you guys in the fall.
Awesome. Thanks, Becky. And maybe throw in the chat the links and things so people can find you.
Of course.
Awesome. Jane, let's come back over to you. So you talked a little bit about what you want to do with this degree, but maybe talk a little bit more about your experiences with projects for underserved communities, and you're completing this humanitarian engineering certificate. What is that? How does that all fit in with this chemical engineering degree?
Yeah, So I'm doing something at UT called the Humanitarian Engineering Certificate. Certificates at UT are kind of like a minor, except they are usually more interdisciplinary. So you'll be taking courses in like several different colleges. So the Humanitarian Engineering Certificate is a combination of courses from clearly engineering, but also like social work, liberal arts, communications, all types of things, all aimed at using engineering to solve humanitarian crises, which I find really interesting because it's such a really important blend of like actual, like you have to have STEM knowledge and be able to like manage a really large engineering project or like a logistical challenge of like providing energy to a refugee camp is an example of something I've like a case study I did in a class before. But it also takes a lot of like social context and awareness and that sort of thing. So really interesting stuff. One thing I did through the Humanitarian Engineering Certificate was a program called Projects with Underserved Communities, or PUC. Basically, it's where these teams of engineering and social work students partner up with a nonprofit in another country. And so in my case, my team was 7 people. It was 6 engineers, 1 social work student, and we partnered up with a nonprofit in India. And then that nonprofit basically like helped us, was kind of the middleman to partner us with a community in India. And then we worked with that community to solve some sort of like humanitarian issue they were going through. So the types of projects vary depending on, the specific community you're working with. Projects with Underserved Communities has done like water sanitation systems. They've installed solar panels in different communities. Right now there's a project going on in Costa Rica where they're like using engineering to level a big field and do drainage to make a community soccer field for the community there. So lots of really cool applications that totally depends on like what that specific community needs from the project. In my case, our community in India was in a floodplain and they had no like higher ground to go to when it did flood, which was basically yearly. So our project was actually just making like a building so that it was kind of looked like a beach house so that the water could go underneath the building. And then in times of flood, the whole community could fit into it so that they had a safe place to go. And then even when it's not flooding, we designed it so that it would be like a community meeting space, basically. So it had a lot of open spaces. It was wheelchair accessible so that the entire community could make use of it. So really, really cool project. I got to learn so much, not just about like civil engineering, because I'm not a civil engineer, but suddenly I had to build a building. So I learned a lot about that. But I mean, you also learn a lot about like cultural communication. You work directly with stakeholders like on the ground in India. We would Skype them every week and be like, hey, can you aim the camera at like the build site so that we can see what kind of dirt you have? Because we need that data so we can do our calculations. So really weird kind of on the fly stuff, but I learned so much from it. And I feel like it's a really, really good way to like put what you see in courses into actual practice and make something tangible.
Awesome, thank you. So again, you kind of hear these combinations of the ways you can put together your interests with the degree and add in those certificates or add in different tracks that you might take within your degree plan, and then even choose different career paths once you head out into industry. So let's talk a little bit about those career paths. I'm going to come back to Brittany and Sarah. And, the questions we often get is, what really do you do in these degrees? What does this work really look like? So can you dive into maybe a little bit more detail about what you do as a chemical engineer, maybe share a project example and dive into those details for us?
Sure. So I'll start. So I guess right now I'm kind of out of the direct engineering. I manage a group of chemical engineers. So at TI and semiconductor manufacturing, we're physically making the integrated circuits. You might have heard that there's a global semiconductor shortage right now. That's because our parts are going into everything from automotive to, home electronics and infrastructure, which have really taken a big step up this last year with everyone moving to work from home. My group's around photolithography. It is the process of using light to print the designs for the circuits on the wafers. So, a really good understanding of, the basic components of like photoresist, so polymers, viscosity is incredibly important, how things flow to make sure that we're covering our entire We print them in called wafers. I can grab one in a minute. I have one by here, but to make sure that it's covering fully, and it's very expensive. So one thing that we're working on right now that my team is working on is trying to reduce the amount of flow that we use. We're trying to cut it from like just about 1 cubic centimeter for dispense to half of that. So, you know, very small volumes, very small scale for everything, but very expensive, complicated chemicals. So anything around volume reduction, ways to make our processes more stable. That's a lot of what we do. Designing new technologies, all of that.
Great.
And I think that's find a wafer.
Yes, you get a wafer, and I'm going to clarify a couple of things. So I think one of the things that I've always loved about engineering, no matter which type of engineering you head into, but with my experience for sure as a chemical engineer, it's all about how do you make things better, faster, safer. You're improving something in some form or fashion. And so what Sarah was talking about, it, you know, trying to reduce costs, reduce waste, improve the process, get it to use less of the materials, all of those kinds of improvements are continual, right? So when sometimes somebody asks, you know, does it get boring? Do you work on the same thing all the time? No, because you can infinitely improve things, right? We're always seeking to improve things no matter what it is. And I think that's that engineering mindset that makes this field so fun, regardless of the discipline that you head into. Sarah has a show and tell.
I do have a show and tell. So this is what I mean when I call it a wafer. So this is how we make semiconductors. So on this one 12-inch wafer, there's about 10,000 components on it. So we process these in batches, like 25 wafers at a time typically. So what I mean, we're trying to figure out how to have things coat this fully so that, you know, you want your pieces on the edge to be just as good as the ones in the middle. Yield improvements to make sure that we can ship as many die out of this wafer as possible at the end of the line. That's a lot of the work that my team does around our specific processes. And then there's other groups in the factory that work on other things like growing films, depositing, plasmas, ion implantation, and they're all working to improve their processes as well.
Awesome. Thank you, Sarah. Brittany, what about you?
Sorry, I was still on mute. So I'll share what I originally did coming out of school and kind of what I've shifted to the past year and a half. And so initially coming out of school, I was very much involved in process design work and project management work, and kind of what Tricia hit on was it was all about improving the process and trying to figure out how we can, you know, run our systems more efficiently, or on the backside of that, if there was something that wasn't operating as well, or that, you know, broke and kind of interrupted our ability to process at the facility, we were working on how do we fix that. So my job was essentially to identify the issue, come up with a design that we could implement relatively in a cost-effective and safe manner as quickly as possible. And then once we transitioned from the design phase, I moved on to the project phase where I managed the design team, was over procurement of the materials and also over the construction phase of the project. So it was a lot of groups involved, a lot of hands involved, but I was really in charge of everything from the design to the installation portion of it. And so as a result of that, I really got a good understanding of how our crude processing systems work. I specifically worked in refineries. And so I got a good understanding of how our crude processing facilities worked, and also how some of our midstream pipelines worked. And there was an opportunity that came up maybe a year and a half ago, 2 years ago now, to where I moved into the role I'm in now, which is commercial asset manager. And in that role, we have two different types of jobs that I do. One is in asset optimization. How do we utilize our current assets as efficiently as possible? And the other part of that is kind of a marketing role, which is very, very new for me and completely different from engineering. But utilizing my knowledge of how the system works to go out and get more business for our asset. So I deal with a lot of our operations team, a lot of our distribution and scheduling team, the teams that kind of make the asset work and making sure we're optimizing the asset as much as possible. But then on the other side, I deal with a lot of customers, kind of going to meet them, determining what their business needs are, and trying to figure out opportunities there to help them meet their business needs, while also bringing additional revenue into our organization. So completely different, but very essential to have, for me, to have the experience that I had in the chemical engineering degree that I had, because that knowledge of understanding how the system works definitely gives you a leg up to be able to go talk to customers, and you're able to talk with them about the system or some of the issues they're having within their systems, and immediately able to offer them solves. And that definitely, helps the relationship building, and also continues to bring more people to the organization because they know that you'll be able to provide them with the needs that they have.
That's great. And I think it was a nice story to talk about how you started with the technical. You have to understand the technical and be able to understand the processes and kind of dive into the details of that chemical engineering, of the engineering. And then you can move into those more managerial roles, the customer facing roles, and those spaces where you can start to connect the dots for other people. Mm-hmm. And really having that technical foundation is really important. And you can't go on and do some of those jobs without that foundation. So I know sometimes people are like, I want to be a manager, I want to get into this other role. And if you haven't gotten that foundation first, then it makes it a little more challenging, or they're just not available to you. Mm-hmm. So that was a great story to show all those connections. And I love that you shared how important communication is, because we talk about that a lot, but you have to be able to communicate all of these things. And so
very, very important. Mm-hmm.
The stereotype of engineers who can't communicate is really a problematic stereotype, because you cannot be a great engineer without also being a great communicator. Mm-hmm. Awesome. Well, I know we have a bunch of questions that have been coming in from our fabulous participant communicators. So I'm going to flip it over to our fabulous Q&A facilitators, Maya and Maria and Sarah, to lead us through some of the questions that you've been asking.
So the very first question that we have is, could you guys talk more about a chemical engineer's role in environmentalism or sustainability?
I can start. The first thing I'll mention is that at UT, at least, I don't know other degree plans, but at UT, the chemical engineering degree plan has a chance for you to like specify on your field that you want to focus on. They're called technical option areas. There are 6 to choose from. I don't remember all 6, but they might be like process design and safety. One of them is like nanomaterials, and the one I picked is environmental engineering. So if you are really interested in environmental stuff within chemical engineering, that's totally an option. It's a huge field of like possible jobs, but you can also like take classes in that at UT. Some of the classes I've taken within that technical option area, I just finished this past semester. I took a course called Energy Technology and Policy. It was one of the best courses I've ever taken. I loved it. All about energy, and well, I mean, the name really says it all. I got to learn a lot about like the policies that kind of dictate like which energy industries succeed or fail. Learned a lot of econ, but I also learned a lot of like very STEM technology about like how we actually get energy from a source to a refrigerator or something like that. So that was really cool. I also took one called Design for Environment. That was another ChE elective. It was actually taught by a professor, Dr. David Allen. He's the ChE professor, and for years he worked for the Environmental Protection Agency as their like science director or something. Such a cool professor. If you are coming to UT soon, take his class. That class was all about basically like policies that dictate how much of a certain type of chemical can like be emitted into air or water or something like that. So kind of like environmental limits of engineering processes. It also talked about kind of like basically if you look at a chemical molecule and you're like, okay, I see this specific type of structure on the molecule tells me that this molecule is going to have a really long residence time in water versus air. So you can basically just look at a type of molecule and know based on chemical principles, like, oh, this is going to need a really intense cleanup effort on like this lake if it's emitted here, rather than like staying in air or in like biological materials, something like that. I thought that was fascinating because I really love chemistry. And so to be able to go from like a very small, like molecular level view up to a macroscopic picture of like, what kind of logistical efforts are we going to need to clean up this environment? That was super cool. That's all available within chemical engineering. Yeah, and maybe because Becky is doing sustainability within UChEW, I'm sure other people have sustainability or environmental stuff within their jobs, so other people can share as well.
Yeah, sustainability is definitely something we see like growing a lot in ChE, like especially if you go to like org meetings. I know AKI, UTWEP, we all have industry people come and talk to us, and they all have these huge sustainability projects a part of their company, like set aside from what they already are doing. Like even these like energy and like oil and gas, like all these companies also have sustainability as like a part of their daily work. For me, something that inspired me to like go into sustainability, Dow Chemical, I don't know if you guys know, I definitely can recommend looking them up. It's a huge chemical engineering company. They had this project going on, and as soon as I heard about it, I was like, I want to be a part of something like that. So pretty much they're like melting plastic and it's just starting to build roads out of them, which I thought was absolutely amazing. I was like, I didn't even know that's something you could do. So there's these little things, and you'll pick up as you start learning and come, and in your classes, like Jane said, you'll start learning about sustainability and environmental, and that's this huge industry that's just continuously growing right now. So yeah, there's a lot of different options. Like Jane, I'm also pursuing like a certificate in sustainability. There's certificates, there's minors. You guys can take these classes that are just offered to you. You can just simply learn about it. But yeah, it's a really cool thing.
All right, next question.
Okay, the next question is basically, what is something unexpected that you found you liked or maybe didn't like about chemical engineering?
I'll share mine while they're all thinking. Mine was that I became a chemical engineer who really didn't love chemistry in college. I think there's some other questions about chemistry. I could do the chemistry, but the chemistry, like the technical chemistry in the lab was not my thing at all. In fact, I remember very distinctly in a lab one time, a lab assistant said, you know, your lab reports are really well written, they're great, but your results are always off. And it's because I was like, I don't care to titrate till just it barely turns pink. I'm like, just dump it and be done. It didn't interest me to be that precise like you need to be in chemistry, and chemical engineering is more about how do you apply it. And while you have to be somewhat precise, engineering has things called fudge factors and always these little air factors you build in so that you have some flexibility in your designs. And so I learned that I liked the application of chemistry, but I didn't actually like the chemistry as a chemical engineer. And that was okay. You can still be a great chemical engineer that way.
I think something that surprised me, and I didn't really like it, but I hope this doesn't like push you off of chemical engineering if it interests you, is that it took a while to just build up the like foundational chemical engineering knowledge to get to a point where I could study things that like really truly interested me as like a career option. That's probably true of all engineering disciplines, but yeah, I like my first 1 or 2 years of engineering was just like coding classes, thermodynamics classes. So like there's a chemistry class called transport, which is a pretty difficult one. And though, yeah, people are making faces, that's a toughie, but you know, you get past them, you end up getting to specify on like, this is what I really care about. It's what I want to research or do as an internship or something. But it took me a while, and it's hard to see when you're taking those classes about kind of like more fundamental like physics of how does heat move through a body, or like how do you transfer energy, or how does a fluid move? Those kind of things, you can kind of get lost in them and be like, man, why did I even like want to do chemical engineering in the first place? Like what was the reason again that this interested me? So luckily I stuck through them. now that I'm in my senior year, I see the application so much more clearly. And I can also see why those classes were useful, because things I'm doing now in my classes or in work, it's like hearkening back to those fundamental classes. So I guess I wish I had been aware of that going in, so that I could know, okay, first few years or something, or I'll take some classes that are kind of going to be a drag, or they'll be really fundamental. I might lose the reason why I wanted to do this, but it will come back and they'll be helpful.
Any other surprises y'all want to share? Go to the next question.
So someone asks, since Texas has many opportunities in oil and gas industry, what % of UTChEW graduates go into oil and gas? And is it rare to go into other areas of chemical engineering in Texas?
I don't know that we know the percent. It's probably a decent amount, because like you said, in Texas, there's a lot of opportunities in those spaces, but that is not the end all be all. You have examples here of Texas Instruments, Seagate, the other pathways that people have taken. Maybe y'all can throw out some places and spaces that you know some of your peers have headed into in chemical engineering.
Well, both of our panelists are working on different things, so they can expand more on that. Semiconductors is definitely a big thing I hear my peers going into. Environmental consulting, a lot of my peers are doing that. Tech companies, I have 1 or 2 friends doing kind of like totally different from engineering, like they're going into business or law school. I have a friend doing Teach for America and going to become a chemistry teacher, Peace Corps. Overall, I would say, I don't know a percentage, but I feel like it's not like overwhelmingly like, oh my gosh, everybody's going straight into oil and gas.
I think, here in Texas, because oil and gas has such a large presence, it's natural to maybe go that route, but definitely if you're interested in anything else, as in my example, having that chemical engineering degree can definitely get you in a lot of doors. So don't think that just because you have an engineering degree that you can't go after other organizations or other opportunities, because a lot of the organizations, as Jane touched on, like tech, law school, I have friends that have gone into the beauty industry, medical school, all either, after a few years of working or straight from college into those fields. So because you have that degree, it can open a lot of doors for you. So don't think that you're just pigeonholed into going to oil and gas. Definitely explore anything that may be of interest to you, because you'd be surprised how many people, see chemical engineering on your resume and, want to just give you an opportunity, even if maybe you don't have a background in it. So definitely pursue any opportunity that comes up that you're interested in.
Absolutely. Some other ones. So we touched on semiconductor engineering. That's a huge one. Space, like aerospace, SpaceX. I had like 5 more off the top of my head. The food industry. So like, the Frito-Lay is in North Texas, Pepsi, all of those manufacturing lines, General Mills, the beauty industry. Brittany mentioned law school. Patent law is huge. To be a patent law lawyer, you have to typically have at least 2 years of engineering experience in like the quote unquote real world before you get accepted to law school for a patent law program. A lot of people will go into business. There's a whole bunch of things outside of, petroleum.
I threw just a few more things there in the chat and our tech electives that are described that can lead you into these different industries and spaces. I think the beauty of a school like UT Austin and a degree like chemical engineering is that it's pretty broad. And you have lots of companies that are coming looking for your ability to think and to problem solve. And that can go into lots of different spaces and places. All right. Maybe a few more minutes, maybe a few more questions we can sneak in.
Another question is, are most chemical engineering courses focused around chemistry?
I would say that it's the base for a lot of them. You know, like Trisha mentioned, she didn't love the chemistry classes, but they are, you know, the base. So, you know, chemical reactions, like solving those necessarily won't be the process, but like thermodynamics has some chemistry in it. I had viscous flow, you know, you got to know basics of like how different things move, viscosity, all of that. At USC, I took a whole slew of chemistry classes. I don't know what the program's like at UT, but I took general chemistry, organic chemistry, analytical, physical, inorganic. So more chemistries and types of chemistry than you could even count or probably even knew were subsets. But then classes like your reactors, your distillation columns, they're not directly chemistry, but they all have that foundation because you have to understand the basics to be able to understand how the chemicals are going to react, you know, in the different applications.
I think I saw a question around physics and chemistry, and I know one of the things I often counsel students on that if you like chemistry in high school a little bit more than the physics, then chemical engineering is a good route to go over, maybe a mechanical engineering if you're trying to debate between the two. Chemical engineering or biomedical engineering or materials engineering, which we don't have as an undergrad at UT Austin as a standalone major, are all the spaces where the chemistry is going to come out a little bit more than the physics. Whereas the electrical engineering, mechanical engineering, civil engineering, the physics is going to come out a little bit more.
For the record, I'm horrible at physics. Horrible. Absolutely terrible at physics. I did okay in every other class, so that didn't kill me going through the degree.
I'll make a good chemie.
I'll second that. I was absolutely the worst at physics, so don't let that deter you. I think I had to take 2 physics classes. I think they went well enough to where I graduated, obviously, but I was not a star student. So.
Okay, it's persistence and grit, right? It's we figure out what we need to do. We get through the classes. Jane even mentioned that sometimes there's just these classes that you're like, if this is what engineering is going to be, I am out. But it's really getting you that foundation so you can get to the fun stuff that really lets you see, this is what I can do to make our world a better place. So sometimes you just have to get through the physics. I love it. All right. Do we have a couple more questions that have come up?
It looks like a lot of our questions are similar to ones that have already been answered.
Okay.
A couple for specific people. So maybe we'll just go to our closing question, which is each of y'all can answer. What is one thing that's been fantastic about your experience pursuing chemical engineering?
Who wants to start?
I'm never bored, ever. Every single day is different. I normally start my day, so semiconductor manufacturing, and the factory is running 24/7. If I'm not woken up in the middle of the night for an issue, I typically say, what broke last night? Like, what's my day gonna be like? Because I genuinely have no idea what's ahead of me for a day before I get there. And I find that incredibly exciting. I'm someone who does not do well being bored. So to have that constant variance is really good.
Awesome. Thanks, Sarah.
For me, I would say it's the fact that I got the opportunity to be in the role that I'm in now. You know, as a student, I always thought that I would just be in, you know, maybe process design or project management, and that's where I would end up, and I was okay with that. But I didn't know what other roles lied out there, especially in this commercial marketing role. And this has been an incredibly tough role, but incredibly exciting and rewarding. So it's just been, you know, fantastic that I was able to utilize my degree and the knowledge that I had to be able to transition to a completely different world. And just be able to pursue that until I maybe determine I want to do something else. But that optionality really to maybe, go in different fields is what's been the most rewarding, thing for me as a chemical engineer.
Awesome. Thanks, Brittany.
Yeah, mine is kind of similar. I love that ChE has prepped me so much to transition into like any field I want to end up going into. I don't at all feel pinned down to a specific discipline. Now that I'm going into my last semester, so I'm starting to look into like jobs and what I want to do after engineering. And I'm mostly looking at like government, foreign policy type of stuff. And even though I'm like, I have less experience with that, I still feel very like, well, not very, I feel qualified enough that I'm comfortable applying for these because the people who read your application, they're still looking for engineers. It's a different type of knowledge. It's a different like training than a lot of the other people they'll have applying. So I still feel qualified to apply for them, and they're really interesting stuff. And I get to see the connections to engineering, which is really, really fun. The other thing, kind of a separate point, is just the people I've met overall. I've had wonderful experience. Like I feel like it's a really collaborative degree. Maybe that's like a misconception, but I've worked like it's really a team sport. So like even late night 2 a.m. homework sessions with people, totally worth it. They're a lot of fun. You meet great friends.
Yeah, definitely about ChE. Like we've all mentioned, it's very broad and it's really easy to be overwhelmed. Like I know my first year I was really overwhelmed. I was like, I have to go into oil and gas. Like that's the only thing. But coming to like sessions like this, just learning about there's so many opportunities out there. I was like, wow, like I can literally do whatever I want. So just keeping an open mindset and be open to possibilities and opportunities that are like allowed to you guys. Just like learn about them. And then yeah, like Jane said, the people that you meet, not even just in ChE, like you'll meet a lot of electrical engineers, a lot of mechies, a lot of different people within Cockrell. And that's always the best part of it. You have these connections, and I'm sure we'll be connected to these people after we graduate. Just be open to meeting people outside of ChE, outside of your classes. Everybody has a story, and learning about each other has definitely been the best part for me.
Awesome. Well, thank you all. I think you hit on some of the fabulous high points that I feel definitely as an engineer. I think, engineering, Sarah started out talking about she doesn't ever quite know what her day is going to bring, but this engineering mindset and this problem solving mindset, it might be scary a little bit that you don't actually know, but we also have this mindset that I can figure it out. And you heard that with Brittany and her story of like how she got to where she is in a field that she never anticipated, right? It's maybe scary to make that jump and that move to go do it, but because we have this engineering mindset, we know that we can figure it out. We know that we can ask questions. We know that we can problem solve our way to a solution, whatever that pathway is for us. And there's so many different opportunities in chemical engineering. So thank you all for sharing your stories, and thank you for sharing all of your examples. And hopefully that helped our fabulous participants understand a little bit better about the different aspects of chemical engineering and what they can do with those degrees. Thank you again, fabulous panelists. Have a fantastic Friday, everyone. We will see everyone next Friday for our electrical and computer engineering FabFems Friday with more fabulous students and alums and engineering friends. Thank you, everybody.